Good morning, everyone. My name is Kwang Yi. I am from the Faculty of Mechanical Engineering and Technology. My title of the exhibition today is about the 3D printed polycaprolactone coronary stent in advancing biodegradable cardiovascular implant. The inventors of this project is basically from the UNIMED and also the USM, University Science Malaysia, for the biological experiment and also testing. Before getting into the topic itself, let me introduce you first what is the coronary artery diseases and also what is the coronary stent. The CAD is basically a type of cardiovascular diseases and it is the primary cause of death in Malaysia. This type of the diseases is basically caused by the plaque formation in our blood vessels, which will narrow down the blood vessels and reducing the amount of blood and oxygen in our body. In order to treat this kind of diseases, the coronary stent is necessary in order to keep the blood vessels from recoiling, to decrease the likelihood of restenosis, and also to enhance the blood flow in our body. This is basically the coronary stent itself. For information, the traditional and the most widely used coronary stent is basically the bare metal stent and also the drug-eluting stent. However, they still have many drawbacks like the instant restenosis and also the lesser thrombosis. The coronary stent is start to evolve into the bioresorbable stent, which will disintegrate over time in our body to solve the problem brings by the BMS and also DES, which is the permanent bone implant in our body. On the other hand, the traditional stent fabrication method, which is the laser micromachining, it can actually cause the problem of thermal damage to the coronary stent itself, particularly for the polymer coronary stent. And it can bring the high manufacturing cost because it requires the additional post-processing in order to remove the debris and also recast formation. And it is also limited to the certain materials only. And from the situation I described just now, you can find that the problem in this area can be actually divided into two. The first one, the coronary stent itself, and the second one is the stent manufacturing method itself. And for the solution, we start to introduce the 3D printing of the bioresorbable stent. The 3D printing here is basically a type of simple and fast process, and it can offer the advantages of low cost, high reliability, and also personal designing. And thus, it can be demonstrated as the promising solution in stent fabrication. And the novelty and inventiveness in this project is the first one, as I described just now. We introduced the Fused Deposition Modelling 3D printing for the polycaprolactone stent, which is the bioresorbable stent. And the second one, we optimize the printing parameters in order to enhance the biodegradability for the better clinical performance. And the third one, we actually achieve the sustainable and cost-effective manufacturing in this area in the stent fabrication. And this is basically the methodology of the project. Throughout the project, the PCL, the polycaprolactone material will be used, and we actually use the method of one vector at a time to design the experiment. And the Fused Deposition Modelling based 3D printer will be used in order to print out the sample. After we get the sample, we're getting into the characterization phase over 33 days, which is we start to immerse the sample into the SPF simulated body fluid, and at the specific time frame, we start to measure the weight of the stent sample and the SPF pH value, and also to observe the structural change of the stent sample itself. And after we get the result, we start to analyze, and that is the analysis phase. This is basically the result of the project. For the first one, we can actually get the effect of the parameters such as the nozzle temperature, the flow rate, and the printing speed towards the degradation rates of the PCL stent sample. This is the first result we can get. And with the decrease of the SPF pH value, we can actually indicate and also verify that the PCL stent sample is being degraded in the SPF. This is the second result. And with this result, we can actually calculate and estimate the degradation rate of the stent sample itself. For the conclusion, in overall, the degradation rate that's suitable for the coronary stent, which is 12 to 24 months for the stent itself to degrade in our body, can be actually be achieved and also fabricated by using the 3D printing technology. This is the advantages of this project. The first one is about the stent itself, the biodegradability. We use the bioresorbable polymer to produce the stent itself in order to achieve the biodegradability to solve the problem brings by the BMS and also the DES. And the advantages of 2, 3, 4, 5 is basically brings by the 3D printing technology itself. So the 3D printing will actually bring the advantage of cost effective, the customization, and also it can reduce the thermal damage caused by the laser cutting, and also it can achieve the scalability. Yeah, so just now I mentioned about the cost effective. So from here, from the news by the Economic Times, we can actually know the price of the market price of the bare metal stent and also the drug-eluting stent, and which is the bare metal stent is 420 ringgit per unit, and also the market price of drug-eluting stent is 1,532 ringgit per unit. So by using the 3D printing technology to produce the bioresorbable stent, we can actually get the estimated cost of 174 ringgit per unit only. So it is actually 58% less than the market price of BNS, and also 88% less than the market price of DES. So it is a huge improvement here. So it can this project is actually significantly contribute to the society with the improve of the clinical outcome in the CAD, coronary artery diseases treatment. And in terms of the economy, it can be actually achieve lower production costs by using the 3D printing technology. And with the nation itself, it can enhance the local biomedical manufacturing capabilities. So this project is basically bringing this area, the stent fabrication, to the more future generation of the coronary stent, which is the 3D printing of the bioresorbable stent. So this project is basically in collaboration with the Kementerian Pendidikan Malaysia, and it is collaborate with the other university like University Science Malaysia and also Saryabama University in India. So this is the patent filing and also the copyright of this project entitled the 3D printing of bioresorbable polymeric stent for the coronary stent application. And this is the support letter that proves that we actually have the collaboration with the industry and also the other university in order to conduct the experiment and testing in this area, in this project. And this project also get the support from the Ministry of Education Malaysia with the research grant of around $30,000. And also this project have a publication entitled the biodegradability assessment of 3D printed polycaprolactone for the coronary stent application. Yeah, so that's all for my presentation. Thank you.